Hi everyone, Dr. Vaughn. I'm going to make a video by request of Chapter 8. This is problem number 4. So we did this one in class, and you have a copy of the Excel spreadsheet that I put up that's got this in one of them. But someone wanted a little bit of extra explanation, so I'm putting this up. All right, so we have these two different kind of proportions going on, 159 out of 485, and then later 93 out of 485. So that's going to be our P, that's our observed proportion, and we're going to compute a 95% confidence interval. So let's just hop over here and just set up a little thing in Excel. This might look slightly different than the other one because I'm just making it up off of scratch. So first we're going to put the total. This is N, and this is the total number that's in our sample, 485. Then I'm going to put the observed, which is what we're going to call X in some of our formulas that we have a little bit later. And for part A here, where we're talking about the technological advances of the global trends that will transform their business, we're going with 159. And then I'm going to put the confidence level, just in case some of you have a different confidence level than I do. Mine's at 95%. So we'll put this in here, 95 with the percent sign. All right. And so I think that that's all of the inputs. We have the proportion, we have the confidence level, and now we need to compute the low end and the high end of this confidence interval. So now we'll go right over to the formula, and you can get this is on slide number 37 from chapter 8. But this is the formula for the confidence interval endpoints, the minus for the low end and the plus for the high end. And this is assuming that we get the upper one of these Z alpha divided by 2, this confidence level that comes from the 95%. So this is the normal distribution where you take alpha, which is 100% minus 95% is 5%, and you split it into 2.5% tails. So this is the cutoff for on the Z, the normal distribution, the setting 95% in the middle from 5% out the tails. Now, this one we use all the time. This particular number, it's going to turn out to be plus or minus 1.96. But, let's have just Excel compute that for us instead of, looking up or memorizing the 1.96. So we'll compute this Z alpha divided by 2. And to do this, we're going to do the find the Z value that separates 97.5% on the left from 2.5% on the right. So this is going to be the upper Z cutoff that determines a 2.5% right-hand tail, which means that you have 97.5% to the left. So we're going to use this normal inverse normal distribution function with the 97.5 below. So we'll do norm.inv, and we'll put in the 0.975. Now, if you wanted to, instead of just kind of calculating this in my head, where'd you come up with 97.5? We could also do something like this. We could do, let's see, we're going to take 100% minus 95% to get 5%. We're going to divide that by 2, and then we're going to add it back to the 95, for the left tail, plus the middle part to get the upper boundary. So we could do something like this. We could get this number here, 95%, plus parentheses 100% minus this number divided by 2. And that should be 95% plus 5% divided by 2 is 2.5%. 95% plus 2.5% is 97.5%. The nice thing about doing it this way is that if you had 90% confidence level or 99% confidence interval, this formula would still work with no adjustments. All you'd have to do is change that field B4 where you have your confidence level. All right, so now we're going to put in your mean and your standard deviation. We're on the normal distribution curve, so we're going to put a mean of 0 and a standard deviation of 1. All right, so this gives us that positive 1.96. If you round it to 2 decimal places, this is the more exact value of it in Excel. So that's that 1.96. That's our Z alpha divided by 2 that we need for this formula right here. So now we're going to program this formula for our confidence interval. And in order to do that, I need to actually calculate P. So let's calculate P, the observed proportion. And that observed proportion is going to be just the quotient of the number that's observed by the total n, which is over here. So okay, we're going to continue now. Sorry about the dogs barking there for a second. They get a little excited. So we're at this observed proportion, which is 0.3278. That was the observed x divided by the total n up here. You know, this b2 divided by b1. Since there's a video, you can always kind of rewind this and pause it in order, so I don't have to, you know, pause on the video for you to catch up if you're trying to follow along at home. All right, so now we're actually going to compute the low end of the confidence interval. And the low end of the confidence interval, according to our formula, is the p, the observed p, plus or minus that z alpha divided by 2 number that we calculated, and then times square root of p times 1 minus p divided by n. All right, so we'll start with equals the observed proportion p minus, because we're doing the low end of the confidence interval, the z number here times sqrt for square root, parentheses. Now we need to do p times parentheses 1 minus p divided by n, and then close parentheses for the square root, and then press enter. So that should be the low end of our confidence interval. And when I go to do the high end of the confidence interval, it's going to be pretty much the same. We're going to do equals the observed proportion p. This time we'll do plus, and then the z alpha divided by 2 times sqrt, parentheses, the p, times, parentheses, 1 minus p, and then divided by n, and close parentheses for the square root. All right, so that should be our low and high end of the confidence interval. Let's go ahead and type it into our problem and see. So on the low end, I have round to 4 decimal places. Okay, we'll make Excel do that for us. .2861. And 0.3696. .2861 and 0.3696. Okay, now for the second part of this, we're going to do a 95% confidence interval with the other proportions. So everything should be the same. We're just going to use 93 instead of the 159. So the nice thing about doing this in Excel is all I need to do is change this number to 93 instead of 159. Now I can type these numbers directly into the homework problem. So let's try that one. 0.1567 and 0.2268. And now we just have an interpretation question, and this is the one that, let's see, the population proportion who indicate technological is 95% of the time. We can be 95% confident that the population proportion lies within the interval in part A. Let's see. Yeah, that sounds right. And it's of all tech CEOs surveyed. It's one of the global trends. What's the difference between A, C, and D? Oh, C is the ones who surveyed. In D, we're looking at the ones that are all tech CEOs, not just the ones that are surveyed. So the answer here is D. Okay, well, as you can probably see from the starting and stopping the video a couple of times, I'm having some internet connectivity issues. So I'm going to go ahead and end this video at this point. The correct answer is here, D, and then I think you have one more, which is just basically interpreting the interval from part B, and it should be a similar response to what you did here for part C. So I hope this has been helpful to you, and I will talk to you next time.